Today we're going to talk about how to use RTBricks in addition to generating a BGP session and sending some route updates. How can we use RTBricks to send traffic for those BGP destinations? I have already posted another video on the channel that explains how to use RTBricks to create BGP session between the RTBricks and the router and how to send route updates and withdrawal of routes. Now this video is a continuation of that. In this video, what we talk about is after we create updates, how do we generate streams of traffic for those destinations? Now the quick details are displayed here. So I have a file to explain it. As we explained on the previous video, we create an update file with all the syntax and parameters. Now to generate traffic for those prefixes, so in this case, I have a /24 prefix, 10 of them. I want stream of traffic created for them. So the syntax is -s. This is just a file name, streams.json. It's just a name. And I say for each of those prefixes, I want 1000 packets per second. Now this is what is being referenced on my config file. Now you can see here. So the config file, the first half of the syntax is exactly the same as we've done in the previous video. So we define the network interface, its address, the gateway in this case is the router, the local AS, the peer AS, the config file. As you see here, the BGP update is telling me that I want to send 10 prefixes for 20.1/24. So that is what you're referencing here with family IPv4 unicast. Now the streams part is something I've added or appended to my config file. So when you create this particular update file, because you've said -s streams.json, it created that template. So now if you were to look at cat streams.json, you can see that. You see, this is having all that information automatically generated, and I am just appending that into my config file at the end of my BGP configuration. Now on the router, right now my BGP session is down, as you can see here. The last state is idle. Now I'm going to start the RTBricks. So I'm referencing. So this is it, bngblaster-s run.sock, the configuration file, interactive. Now let's see if the traffic is generated and it's able to send traffic as well. Now you can see my session has started. My updates are sent, as you can see in the name here. Open confirm to establish, update sends, all stream traffic flow verified, and you can see the packets are going because I have 10 prefixes. Each prefix is having 1000 packets. You can see I have 10,000 packets per second going in and out of the router. Now on the router, on the BGP neighbor, I can see my session is established here and the prefixes are 10. So if I look at the prefixes I received, here are the 10 prefixes, and if I look at the interface on the Juniper, in this case, I can see those 10,000 packets coming in and going out. I have also enabled a firewall filter to demonstrate. Let me check the interface that's facing the RTBricks is this one here. So show firewall log detail. So it's even telling me what is the source and destination. You can see all the source address of my packet is from the RTBricks, but the destinations are all unique or based on your BGP routes that you send, and the port numbers are here. Now of course you can manipulate port numbers and protocols, so that I will explain how it is possible. So here it is all running. Now if I look at one more important detail, you can even give an additional command to look at the flow details. So let's say if I pick a flow ID as 1, so I know there are 10 flows, right? So it's this command bngblaster-cli stream info flow ID. It can tell me what is the flow details as well, the destination port, the protocol that is being sent by the RTBricks. So in addition to that, I also wanted to explain that I've created one more file where you can even go and update your stream information to have different protocols. So this is a cut down version of the config file I was showing, which is GAT1 previously. In GAT2, I have all the relevant files, but the streams have reduced from 10 to just 1. But you can see the key part here is you can even define the source port, destination port, and even the length of the packet. Because when we checked on the router, by default, the packet length is 128 bytes. The protocol is UDP. Of course, you can manipulate it and send a higher length, a different source port, destination port. So this is all possible through RTBricks. Hope this is useful. Bye for now.